put this poll up, and you guys voted for super short takeoff and landing cargo planes. So here it is, the giant cargo plane. Now, I built RC cargo planes in the past. However, they fly slow because they have a lot of engine horsepower, and they also just vector the airflow over control surfaces to kind of like fly like 3D, like these RC airplanes that do tricks and stuff. However, that's not that interesting from an aerodynamic standpoint. I saw this really cool video from NASA about this QSRA airplane, or Quiet Short Haul Research Aircraft, and the YC-15. Wait, did I say 15? I meant the 14. This is the YC-14. I actually went to the Pima Air and Space Museum in the desert to check out the real thing. It has all these aerodynamic trickery, such as these upper surface blowing, these big flaps, and this giant T-tail. It's a really cool plane. This is an aircraft that is a mashup of the two. So this video is going to specifically focus on aerodynamic tomfoolery and tricks to make our airplanes fly as slow as possible. I have these airliners, and I want to see how they fly if we do this upper wing mounted engines, because it looks super cool. And the concept behind this is exploring the Coanda effect. It's when you blow air over a surface and it lifts up. It has to do with air kind of attaching to the surface versus just glancing off of it. So we're going to try with this airliner first as a control, because I have a regular airliner and this modified airliner. Now in theory, the modified airliner should have a lot more lift and a little bit more drag and lift itself up the ground much sooner than the regular airliner and take off much shorter. So I have a plane, and we're gonna test this first with a stock RC airplane. First, I need to flatten this grass. Okay, that's a pretty long takeoff roll. The only thing I really did to modify this airplane was to add a little bit of flaps into it, because I want to see how slow I can get it to go in a stock configuration. This is the modified airliner. It has the engines on top of the wings because the ground crew didn't quite get the instructions right. The airliner may not be the optimum platform for this, so this may be kind of a waste of time. I may end up smashing this model into the ground, because I think the elevator may be a little small, because every time I see these cool cargo planes, they always have a big T-tail, so the tail is operating in undisturbed airflow. And I want to see a stock comparison on one airframe versus the other. Hopefully this induced Coanda effect really helps pick up the airplane off the ground a lot faster, so the takeoff roll is a lot shorter, and ultimately makes our cruise speed a little bit slower for short takeoff and landing performance, because that's what we're here to test. Whoa, it really behaves differently. And not a good way. I think the elevator might be a little bit too small on this. So maybe this is not the airliner. Okay, well that was kind of lame. It wasn't really what I was hoping for, but I have a reason why. The elevator itself is too small, so we're going to modify this airplane because I don't have enough pitch authority to kind of wrestle this plane off the ground, because I see it trying to get off the ground. I noticed it trying to do wheelbarrows because the back of the wing is sucking itself off the ground and causing the plane to do nose wheelies. However, the elevator surface, which is responsible for pitch, doesn't have enough authority to push the plane and then increase our angle of attack so we can take off and do airplane stuff. So this is what we're doing. I think this is going to make all the difference we need, so it should be able to take off a lot sooner. We have enough pitch authority now. However, the wings aren't really up to producing lift at these slow airspeeds. You can see it stalling and dropping wingtips, and it's hard to get off the ground, but I can still force it. That takes off in a fraction of the amount of area the last one took off. That is really well pronounced. Okay. I didn't do a very good job of modding this because I maybe spent like 3 minutes gluing this new elevator on, and it's clearly about to come unglued. But wow, that is such a difference. But you know what makes a bigger difference? If we build a purpose-built airframe designed for this research experiment. So let's do that. We have the wing design in CAD. It looks super cool. I'm really kind of pulling out the stops here to make this thing really fancy. We're gonna cut it out on our laser cutter. It's gonna be very fancy. It's gonna be tapered back to look very jet-like, because I think that's really cool for this project, because this project has to look cool too, to really do well in the YouTube algorithm, because my videos are doing terrible in the algorithm, so hopefully this makes things better. For this plane, we're gonna explore some new concepts. I'm using traditional balsa wood for the frame of the wings, for the spars and the struts and some of the ribs. However, we're gonna explore some cool stuff. I'm gonna glue some Depron foam to these because it's super lightweight and it makes a very aerodynamic skin. Now here's the neat part. For the front D-tube area of the wing, I'm gonna 3D print this whole thing and glue them on because it's very, very nice and uniform, and it saves a lot of time. For the fuselage, we're going to use some of this foam that I have laying around, and it's just one of my normal cargo plane designs because I got plenty of these things, and why change something that doesn't need to be changed? We have a T-tail to really take advantage of clean airflow. Now we're gluing on the trailing sections, 3D printed hinges, 3D printed ailerons, 3D printed flaps. Look at this, I got cool flaps. So we're just testing this plane first. We haven't added all the thrust augmentators and doohickeys on it. It's currently just top mounted EDFs, the inboard flaps, and we have this normal ailerons. I plan to do flaperons where the ailerons droop and move like ailerons and flaps, but let's just make sure this thing flies first. So we have ailerons, typical rudder, elevator, and throttle. I definitely don't build wings like this normally. All right, we've entered the runway. Testing grounds. It's super dark out here. I'm not sure how I'm gonna see this airplane, but we're gonna figure it out. Here at the airfield, ready to test the plane for its first crappy flight. Right, Dave? It's way too dark to do this, but hey, I wanna fly. All right, we're gonna take off. Oh, that's nice and slow. Oh, that was scary. Let's do some flaps. It's pretty slow. I think this is gonna be pretty good. I need to add the augmentators and maybe some leading edge slats. And I think it can go even slower. I broke it. Ooh, I ripped the mount out. Okay. I was a little bit too aggressive on that takeoff and caused the wing to stall. We flew the plane yesterday, it crashed. I didn't like a few things, so we're gonna do a few changes. Man, I have the dirtiest shirts. So now, I've ripped off the front of the wing and changed the angle of incidence because in the last crash, the plane was going fast and I pulled back to increase the angle of attack, make the plane pick up off the ground. But when I did that, the outermost parts of the wings, I think, stalled because there's no like any sort of like boundary layer control or any sort of like aerodynamic devices to keep the airflow attached to the top of those wings. Not only am I increasing the angle of the wing so the plane can take off more naturally versus having to go fast and then pitch up, I've also put leading edge slats, which are boundary control devices. They help keep the airflow attached to the wing so the wing can actually produce lift. Because once the wing becomes turbulent and basically stalled, you lose lift and it becomes basically useless. To demonstrate that, I've cut these little tufts out of tissue paper and attached them to the wing. Ooh, it's so NASA-like. We're doing all these cool wind tunnel experiments. Oh, I also built a wind tunnel. If you guys have seen my channel for a while, I use this on another project with the little infinite flying gliders. You should definitely check it out. Oh, it's still turbulent though. We have the aerodynamic straightener because I want the airflow to be very straight and uniform as it hits the wing to give us more validation testing. I mean, we can just go fly it, but this looks cool. We might as well just do this. But look at this. So that's cool. So let's see what it does. So I'm gonna ramp this up to about half throttle, and then we're gonna increase the angle of attack, and watch these little tufts start to get kind of turbulent and get not stuck to the wing. So more angle of attack like this, it's fine. But when we increase it, you can really see over here. Big. So over here, you just go past. It's trying to go over here. End up with stuff here. You can't hear anything, can you? Well, that actually works. As we increase the angle of attack, the airflow doesn't want to stay attached to the wing. It wants to stall, which basically means it becomes turbulent. It doesn't stay laminar and stick to the wing and produce lift. So you see the little tufts here, because the airflow is spilling this way and becomes turbulent, it rolls like this. Definitely 100% totally useless when it comes to making lift. But these slats here, these take some of the air and inject it to the top of the wing, keeping these tufts attached to the wing so my ailerons become more effective. This is definitely like the most complicated wing I've ever made for a toy airplane. Look at this slat. I love 3D printing. It's so cool. This thing came out so well. It looks just like a real slat on an airliner or something. So hopefully this prevents me from dropping a wingtip when I'm trying to fly slow. Now for the real cool thing, the thing that really made this plane catch my eye, the top-mounted fans, the airflow augmentator. I have no idea what this is called, but anyways. This is pretty cool. I think what's gonna look even cooler if I get a fat vape and blow a huge smoke trail along this. All right, I got the airplane drugs. Alright, so now we're gonna extract the vape juice. Now that we have this vape, we can rip it with this suction thing I found. Here's the wing in a normal flying configuration, not high angle of attack. It looks pretty normal. Now here's the stalled portion of the wing on the interior without the slat. You can see it really tumble and the air doesn't look very smooth. Now here's the section with the slat. You don't see that tumbling as much. It looks like it's kind of delaying the onset of that stalling. Only thing to do now is just to go fly it. Okay, it's raining. It's even worse, but we have an indoor event tomorrow where I'm gonna fly this thing, so I have no choice but to test it in this crappy pouring rain conditions. Oh, that's so much slower. All right, ailerons are good. Wingtips are good. It's not dropping wingtip anymore. Oh, this flies amazing, amazingly slow. Ready for the real show? Cool. We flew around inside. However, this thing is still just a little too fast. I'm not done modifying yet, so back to the drawing board. These flaps are kind of trash. I'm gonna design some way cooler, fouler flaps because we just have the normal split flaps and I'm not happy with them. This looks so much cooler. It looks way more airplane-like. My flap tracks are a little sticky. I got this tub of graphite powder to lube my flaps with for actual airplanes. I think the landing gear is a little bit too solid, so we're gonna upgrade it with this nice springy landing gear, which is just using some rubber bands, because I think this will really help with some STOL landings. The idea here is that rather than my split flaps, which are very sharp and right angly, this graceful curve will allow the airflow to stick to it and promote that coanda effect a lot more effectively. We finally have some clear weather here. This is probably the first time I can fly this without being pressured because of rain, wind, and tight environments. It's already been modded like once, but I think it's gonna be so much better. So let's try taking off. This is just normal stock configuration. Hopefully nothing bad happens. Something bad happened. Oh, that's off the ground in no time at all. Wow, it's so slow. I'm pulling back on the elevator a bit more to slow the plane down, and it's rock freaking steady. All right, I'm gonna put the flaps down even more. All right, this is flaps up, hang on. This is flaps down all the way. Oh, it gets slower, that's crazy. All right, I can see the wings not super stable. Wow, it's like not moving at all compared to the ground. We have a little bit of a headwind that I'm flying into, about 5 miles an hour or so. Okay, I'm coming back towards us. This thing is so slow. This is amazing. Oh, battery's dead. I'm so happy with this. It flies so good. Cool, it really freaking works. Like, slowing down, dumping the flaps all the way, and the slats, it really has really good control response. It does obviously get sluggish because when you fly a plane slower, you have less airflow over the wings, so the ailerons, the elevator, and the rudder become more ineffective, which is to be expected when you fly a plane towards the end of its limits. For my next trick, we're gonna put these little NASA-style tough things on the airplane because these really help you visualize the flow across the wings and stuff. So this is gonna look really cool, and it's time for another flight test. Alright, my plane has now caught a disease. It's called aerodynamics. We're gonna go up and down the runway. Alright, I have this sick chase vehicle because I want to see this happen in real time. Because I'm going to adjust these flaps on this wing and really visualize these tufts go crazy at different angles of flap settings and flight speeds. So we're going to link up with the chase vehicle, and here we go. Alright, the flaps are now at the midsection, and I can see it kind of tumbling a little bit, but it's not crazy. We're going to stabilize this flight, catch up to the plane again. It's not as stuck as I thought it would be though. The flow is kind of turbulent at the very bottom of the flaps, so I don't really think this thrust nozzle is as optimum as it could be. It's really fun flying around and chasing this thing and really seeing it up close. Really cool. Here's flaps completely cleaned up. Now the plane flies too fast and just basically flies away from us. Flaps all the way down, and you can see, wow, at the bottom it's really kind of turbulent, and I don't think the airflow is very attached, so the command effect is not as prevalent at the very bottom. Flaps all the way up, pick up some more speed, and we zoom away. One thing to note, it's extremely stable and very easy to control at almost all these airspeeds. Alright, not bad for a day's worth of work of trying this thing out with the upgrades. I think though, we could do a little bit more upgrades because I have some ideas. Because I do notice during the stall test that it's still pretty aggressive. Once it reaches a certain angle of attack on the wings, it develops into a full stall and drops the wingtip very, very hard and enters the spin. I want to work around that. I'm gonna cut. All right, I watched this really cool old video. We've done the slats, but I didn't realize you could do this. You can inject air across parts of the wings to really control that boundary layer and keep it from separating. So we have to explore that next because this video shows you some really cool promising results when you inject airflow in the right spots to really control that boundary layer in the aerodynamics. Okay, the supercharger is done. So I'm going to build this cool thing, which is basically just a split end of the compressor stage of a turbocharger, and we're going to pocket this thing into the wing and then blow air across these slats that I'm going to cut out. Because when I designed this wing, I actually designed it with this in mind. Got the upgrades. Check this out. Get over here. Look at that. Isn't that cool? So it's like a sealed pressure vessel, and we can inject airflow through these sections here, and thus have airflow at basically any speed. So the airflow should technically prevent the wing from stalling, and the plane shouldn't drop a wingtip anymore, or at least not drop a wingtip nearly as aggressively. Isn't that cool? So basically, we shouldn't stall. You could even see it pull the air over this. So you can watch as the smoke comes over the wing. It literally gets sucked down into the wing, and it stays attached on the top. It's pretty cool. So that's the airflow. It should stay attached to the wing. I'm going to upgrade these nozzles too, because during that flight test, I don't think it was as stuck to the wing as I thought it could be, so I made these new fat ones with these little airflow vanes to hopefully fix this problem. Now, it's time for some more wind tunnel testing. I'm super excited to try this smoke thing out. So unfortunately, we have to increase the angle of attack even more, because these slats right here still do their job. So break out the jack stands and let's raise this nose up and really try to stall this airplane. So here it is with the blowers off. They are not assisting this, and you can tell now we can get that turbulent air to really show up behind it and tumble and really show that we're not producing as much lift as we could at this angle of attack. Once we crank this sucker up though, it's going to be very different. Turning the suction turbocharger on, you can see the smoke get pulled into that. This has got to be the most advanced RC plane wing I've ever built. It's got the leading edge slats, and it's got this cool turbocharger thing attached to the wing. Now it's cool, we're running this thing at a low throttle setting right now, and you can really start to see the smoke kind of try to stick to it, but when we really crank the throttle up, it really becomes a lot more pronounced. And you can really see that smoke staying attached to this wing, even at this extremely high angle of attack. So hopefully this means my ailerons are effective at, basically zero airspeed, and we can fly this plane without dropping wingtips and without having that nasty stall characteristic. And when you turn off the blower, you can see the turbulence come right back and it starts spiraling again. It's kind of amazing. And we're also testing the blower slat. I don't know how restrictive this is going to be with airflow, but it seems to help a little bit more. We are back at the field. Will this plane work with all these crazy mods such as the thruster, the slats, and the crazy new engine fans? There's only one way to really find this out. Look at that takeoff, that's amazing. That's the shortest I've seen it yet, and it's fully controlled. As you've seen in the first model with those little RC airliners, they kept slamming wingtips and everything. This plane, however, just rockets off the ground with rock steady aileron control, and now we can pull the flaps up and fly like a normal airplane. It's truly amazing how well this thing is working. Although I'm starting to think I have a little bit of reduction in power. Maybe these nozzles on top of the wing are restricting my airflow too much. Let's also do that stall test. I'm gonna stall now, bring the car back, the elevator, whole thing. That's not too bad. Okay, well, it's not really fully stall proof, but it seems a lot more benign, and I can kind of recover from the stall a lot faster. Oh, my rubber bands! Oh, that thing broke. Okay. So we didn't run out of battery, but we ran out of ESC power because they were not happy. All right, let me take it back and see if I can repair this and see if we can fly again. All right, let's try it again with the thrusters on because I had a little incident. It is now repaired. But the good news is, I think they'll hire me at Delta to be one of their captains because I don't flare before I land. Stalling now, turning on the thrusters. Now we're gonna stall. Oh, it recovers faster, whoa. It's really weird. There's the wingtip drop. But it seems like they do a little bit of an effect. Anyways, I'm gonna rip these ducted things off because right now I think these things are really robbing me of power. I think I may have designed these wrong. I think the upper surface blowing is still apparent without them. We're gonna take off again and see if there's an improvement. I know there'll be improvement as far as power goes, but as far as like flying in general, I think it's gonna be way better without these. I may try one more thing where I repeat what I've seen online with the real QSRA plane, which the duct is shaped a certain way, but it cuts off. None of this airflow shaping I have going on the backside like a vacuum cleaner. So these will come off and go on my vacuum cleaner instead. Yeah, that's off way shorter. I got way more power. This plane looks really cool taking off this paved runway, but you know what's really cool? Cargo planes taking off from really shitty roads and runways. So let's go find a really crappy dirt road and put this plane to its full test and see its full potential. And maybe kick up some dirt clouds too. time to really fly this airplane, I'm really getting used to it. And it flies super fantastic, especially because this is a ducted fan RC airplane. It's not like my normal RC airplanes, which have just tons of horsepower and blow air all over the control surfaces, which is the thing we're set out to not do here. This is all aerodynamics that you're seeing to accomplish this slow flying airspeed. It's all just really good wing design, thrusting, and all this other stuff going on that really makes this plane fly the way it does, with the leading edge slats, the wing blowers. I can really push this plane around way beyond a normal ducted fan RC plane. You really wouldn't see an RC airplane, especially one with jet engines, fly anything like this, unless they're just specifically vectoring the thrust around, but that's a different story, and that's not what we're here to explore. Also, the landing gear is working out fantastically. It's very springy and really softens the blow when I really stall this plane and slam it into the ground. Time for a high performance takeoff. I'm going to grab onto this tail, run this engine up, and then we're going to release the beast. It's so strong, that Coanda effect from these blower things, that the main gear comes off almost before the nose gear does at some point. So you'll really see it when I come around for some of these landings. Here's some of the landings so you can really see that landing gear bounce around. I also don't realize how much my engine EDF mounts flex around too. Let's do another high performance takeoff and let her rip. Powering up, release the plane. We're rolling and rolling, and now you can see the whole right side comes off the ground right before the nose gear does. It's kind of wild how well it does that. And I'm not commanding that with any elevator. The plane naturally itself just does that. Would you look at this? I have tiny drones. BetaFPV sent me these really cool drones, the Air 75 and the Meteor 75 Pro. I think this is the Pro. We have this cargo plane, and I have this tiny drone. The tiny drone fits inside the cargo plane, so what should we do? Let's try to fly these things out of the cargo plane, and then try to fly them back in. I'm a mediocre pilot, so I've been trying this thing for a while. It's going okay, but man, I can't just seem to... Oh, look, we got... Oh, okay, maybe not. This is as close as I can get. I've been trying for quite a few packs, and I just need to work on my game a little bit more. But hey, these things are pretty much indestructible. I haven't broken from any of these flying like experiments trying to get it in here. So if you guys want to check out some FPV stuff, highly recommend checking out the Air 75. I really like this one and the Meteor 75. These things are just amazing flying drones. Big thank you to BetaFPV for sending me these things. I would love to test out more drones because these are just a lot of fun, and I really like FPV. These drones are a ton of fun, but this cargo plane itself is pretty next level for me. I've never done an airplane like this that has all these crazy aerodynamic effects. The flaps are cool, the slats are cool, and the turbocharged air blower. I don't think I've ever really seen anyone do that on an RC plane. So that really made a really cool cargo plane, and I was really happy to test all this stuff. Super fun. It was a little bit of a challenge, designing this new wing and all this stuff and building a plane like this, which I've never built before. If you guys want to see more stuff like this, definitely comment what sort of aerodynamic gizmos and doodads I should try next, because I'm always looking for new video ideas, and this was a ton of fun to try.
shorter than that.